Now, when I think about all of those points on the unit circle, it's an awful lot. But if we use the properties of our ratios, we can make that a little simpler. So let's look at this example here using theta equals 60 degrees, 120 degrees, 240, and 300. I hope you recognize that for each of these, theta is going to have a reference angle of 60 degrees. So I want you to take a moment and fill in the sides of this triangle or fill in the points on the unit circle at 60 degrees. Remember, if our reference angle here is 60, 60 degrees less, 120 degrees here, 60 degrees more, 240 degrees, and 60 degrees less, 300 degrees. Fill in the sides of the triangle, fill in the points on the unit circle. So you should have at least known the points on the unit circle for 60 degrees. And then using symmetry, all you had to do was change the signs. In quadrant 2, x is negative. In quadrant 3, x and y are negative. And in quadrant 4, y is negative. So let's use that to find our values here for the sine of 60 degrees, 120 degrees, 240, and 300. So remember, we're looking at points on the unit circle. So sine is equal to y. At 60 degrees, sine of 60, root 3 over 2. 120 degrees, root 3 over 2. At 240 degrees, negative root 3 over 2. And at 300 degrees, negative root 3 over 2. So we see, because our reference angle is always the same, we're always using root 3 over 2. The only difference is that in quadrants 3 and 4, sine is negative. Find cosine and tangent for each of these angles now. You remember that cosine was equal to x, and we see that cosine is negative in quadrants 2 and 3. Tangent, y over x, was negative in quadrant 2 and 4. The numbers are always the same because the reference angles are the same. The only thing changing was our sign depending on the quadrant we were in. This means that I only need to memorize quadrant 1 from the unit circle and then determine which quadrant I'm in. By using the cast rule, we can determine whether the functions are positive or negative. So if we think about it, in quadrant 1, x and y are both positive. That means that all of my ratios are going to be positive in quadrant 1. And we've been seeing that most of the time when we were looking at 30 degrees, or all of the time rather, when we were looking at 30 degrees, 45 degrees, and 60 degrees, we had positive answers. In quadrant 2, where y is positive and x is negative, well, think about this. Sine has y, but cosine and tangent both contain x. If x is negative and y is positive, then sine is going to be positive in quadrant 2, sine and its reciprocal, cosecant. What about in quadrant 3, where y is negative and x is negative? If x and y are both negative, then tangent is going to be positive. Cosine and sine are going to be negative. So here we can say that tangent is positive, so is its reciprocal. In quadrant 4, that leaves cosine, because cosine is x over r, and x is positive in quadrant 4. So cosine is positive here, so is its reciprocal, secant. We can use that word cast to help us remember cosine, all, sine, and tangent. If you just stop a moment after you answer a question, think about the quadrant you're in, and think about what should be positive there, you're more likely to get your answer right. Because the most common mistake I see outside of not memorizing the ratios is positive and negative errors. And we're going to take a lot of marks off for that because it's important that you recognize the quadrant makes a difference to your answer.